Welcome to Penrose Learning, where we make understanding easy.
You start by deciding the confidence level you need and immediately compute alpha, because Z star depends on that probability. Once you have alpha, choose one-tailed or two-tailed. For most confidence intervals, use two-tailed, so split alpha in half. Then convert the tail probability to the cumulative probability required by your tool. Make sure to pick the correct direction, upper critical value versus lower. These choices lock the numerical target you will invert to get Z star. Once done, compute the cumulative probability corresponding to Z star. For two-tailed, use 1 minus alpha over 2. For one-tailed, use 1 minus alpha. Next, feed that cumulative probability into your inverse normal function, inv-norm on calculators, qnorm in R, or the z-table lookup for the closest area. As you compute, check that your calculator expects means 0 and SD1. If you get a negative Z, flip sign appropriately to report the positive critical value when convention requires it. You finish by rounding Z star to the precision your analysis requires and inserting it into the margin of error or hypothesis test formula. Make sure to keep track of sign conventions. Critical values for symmetric intervals are positive magnitudes. If the computed Z asterisk yields unexpected intervals, troubleshoot by re-evaluating alpha, whether you split it for two tails, and confirming the inverse function uses the standard normal. A quick recheck usually reveals the single input error causing the mismatch.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.